Jumping right into formulas, if you are having trouble remembering what all these terms mean, there is a motion terms video that I have linked that you can use just as a reference. It's actually something I prepared for college course, but it might help you just remember all the terms. So if you need to, please go ahead and use that. Otherwise, let's just look at these formulas that you have definitely used in your grade 11 course. And the whole idea with the kinematic formula is you want to be able to solve. The goal is to solve for velocities, displacements, accelerations, times, finding something given a bunch of other information, right? And there's always these tons of examples, different problems that we do around that. So we'll look at the formulas again, and then we'll apply them again in this, and that's what we're going to do in this little note. So if I go too fast, go ahead and pause the tape. We should have most of this written down. Okay, so these are two of the formulas. Looking for, and the idea is you choose the formula based on what's not given in the problem. Okay, what you're being able to look for, and then choose the right formula. The big thing this year that you need to consider is being able to rearrange these formulas, and that's my note down here at the bottom. In grade 11, you really could get by having the rearranged forms all written down. There's enough rearranging and enough different formulas in the grade 12 course. You really got to be able to do the rearranging on your own. There's just too many things. You can't write it all down. You're going to have to practice rearranging these formulas, and you can use the examples to do that, and you can do some extra practice on your own, because I'm not going to spend a lot of time doing the rearranging either, because I'm going on the assumption that by grade 12 physics you can do some rearranging of formulas. Okay? So let's look at using the kinematic formula to solve a problem. You should have this written down in front of you. We're just doing a simple find the acceleration. Okay? So here's the solution over on the right here. First of all, notice that when I list my givens, this is kilometers per hour. So right away, I remember that got it into meters per second, and you may or may not remember that you just really, in your calculator, you're just dividing by 3.6. But I do like to see a good, usually on every test when it's applicable, I like to see one full rearranging. And to remind you what this means, if I want this in meters per second, I write it out as kilometers per hour. I multiply it. Remember, this term right here is really just 1. I multiply it by 1 because 1 hour equals 3,600 seconds. So 1 over 1 is just 1. So I write that out. So I'm not changing the number because I'm just writing 1 here. And same thing, 1,000 meters is the same as 1 kilometer. So that's just multiplying by 1. And the idea is that then I want to get rid of the hours, so I can cancel these hours here, one on the top, one on the bottom, and I can cancel these kilometers. And that leaves me with meters on the top, seconds on the bottom, which is exactly what I want. Okay, and that's a full unit conversion, and I like to see that. Anyways, the other things I know, it's coming to a stop, so V2 is 0, right? It's given a time, and I'm looking for acceleration. So I just choose a formula that doesn't have a d in it, because if you look, I haven't written down anything about d here. I took everything from the problem, wrote it down, there's no d, so this is the formula I choose, and obviously it's a pretty simple thing, just substituting in and solving. I say here, the idea of putting a check mark on your answer if it's reasonable. How do you know? Well, it's, in these simple motion problems, you generally say, okay, if it's between -10 and 10, that's probably a good number. Sometimes they're bigger. I mean, if it's an extreme case, something like an odd thing happening, you will see numbers that are different. And certainly when we get into, dealing with electric fields and motion of subatomic particles, the numbers are no longer sort of simple. But for our point of view, between -10 and 10, it's good. And of course, the minus makes sense because it's slowing down, coming to a stop. Another example, same problem, all the same givens, and we're just looking for how far it travels. So here again, write down the things you know. I could also write down A as -2.2 if I wanted to, but we can use any formula we want because we know everything. So just choose a formula. I just usually choose the one that's rearranged for what I'm looking for. So I'm looking for D, so I'll find a formula that has a D by itself, right? So there we go. And again, when I think about reasonableness of an answer, I'd say 100 meters to come to a stop from 75 kilometers is probably a reasonable number. again, I'm going through quick. Feel free to pause the tape. This time, different case. I've got a bicyclist. He's accelerating, or she. Initial speed of 5 meters per second. This is acceleration. That should be a superscript up there. Just determine how fast the cyclist. I'm looking for a V. Oh, I didn't do the kilometers per hour. Whoops. After accelerating for 22 to 8 meters. So I'm given a D, an A, a V1. I want to find V2. Notice again, there's no time here. So I just go ahead and choose a formula with no time. Substitute in and solve. I didn't do this part here, and I'm just going to leave it actually. But just so you remember, if I was going to do this, I would just take my 9.5 meters per second and multiply it by 3.6. So it's going to be about 35 kilometers per hour. I guess I only get level 3 for this one. Anyway, but 9.5 meters per second is a reasonable answer for a cyclist. Okay, this time, I threw this one in here to remember that sometimes they're not always acceleration questions. We know Peter travels 18 meters in 3 seconds, average velocity. If you're looking for average velocity, it's almost, we call it a uniform motion question, and it really is the easiest case. Okay, and the easiest case is just average velocity is distance over time, nothing to it. So, if you're given something like that, it doesn't always have to be as difficult as finding a big, difficult kinematic formula with acceleration and V1s and V2s. Average velocity, just distance over time. Okay, and once again, though, for Peter sprinting, 6 meters per second is not a bad number, a reasonable answer. I'll check mark it. Okay, I think that's it for this note. So that's the review. Any questions, of course, you can ask. And there'll be definitely some of your assignment questions will be just some straightforward one-dimensional kinematics problems.